welcome to the latest episode of Sustainability Forward, our podcast. Today, we have yet another special episode where we will talk about the 9 planetary boundaries of the Earth. My name is Rishi, and with me is my co host, Carmine.
Hello, Rishi. Yes, new episode today, another special episode, but today this is a really important one. We'll talk about this recent article published last September in Science. The title of the article was Earth Beyond 6 of 9 Planetary Boundaries. This article is about our planet's health and well-being, and it references this planetary boundaries framework as a blueprint of our planet's stability. But Rishi, please help me to introduce this concept.
Yes, essentially, this framework identifies the 9 critical processes or boundaries that keep our planet running smoothly. So, if the planet is within these 9 boundaries, then the planet runs smoothly. In fact, these are the parameters that ensure that the Earth is in a state of that is conducive for human life, almost a Holocene like interglacial state.
Yep, the Holocene period, and probably Rishi, we should have a dedicated episode on it for what it has meant for the humanity. So
Mm.
basically, in the past 10,000 years, so just following the latest ice age, the agriculture and modern civilization evolved, and this was because they were helped by stable and warm planetary conditions. So today, this very delicate equilibrium is at risk. Now, the beauty of this framework from this article is that give us a tangible markers to understand how far we're moving from that ideal baseline. And it's not just about vague concepts, it's about specific thresholds that we shouldn't cross if we want to maintain a stable, hospitable Earth.
Yes, indeed, Carmine. So each of these 9 boundaries has been scientifically quantified, through the use of control variables, planetary boundary, pre-industrial Holocene base values, and threshold of risks. It's these boundaries are kind of like a thermometer on multiple dimensions that give us a scientific approach to understand how far we've gone so far in terms of exceeding these boundaries.
Yep, and we are not going so well, unfortunately. So the research shows that 6 out of 9 of these boundaries are already transgressed. In addition, one of them, the ocean acidification, is approaching its planetary boundary. But let's deep dive in each of one of them. As this is a complex topic, maybe today we'll just discuss 5 of them. So we'll focus on climate change, ocean acidification, stratospheric ozone depletion, freshwater use, and land system change. And we'll complete the other 4 in the next episode. But please help me to introduce the first one, Richie, so will be climate change.
Yeah, obviously, a topic that is on a lot of people's mind these days. And unfortunately, on climate change, the safe limit, as identified by scientists, is only 350 parts per million. But here's the alarming part, right? We are far beyond that safe limit. The current levels, for CO2 hover around at 415 parts per million, and they're still continuing to rise.
Yeah. These numbers are not just statistics. So we experience every day what they mean in terms of real impact. So from rising global temperatures, more frequent and severe weather events, and rising sea levels. Of course, it's a domino effect with one change triggering another one.
Yeah, and while the natural processes have always influenced Earth's climate, the rapid changes we are seeing now are driven by human activities. So for example, deforestation, industrial processes, and our reliance um, on fossil fuels, are some of the major culprits. But maybe, Carmina, let's go to the second one, uh, ocean acidification. Um, We already said earlier that we are at the limit of the safe operating space here, and we need to make all efforts possible to stay within that boundary.
Yeah. Also because let's remind us, so our oceans are vast. They are covering 70% of our planet's surface. They are not just bodies of water, they are crucial regulators on Earth climate and carbon cycle.
Yeah, and actually, our oceans do us a huge favor. Um, they absorb about a quarter of the carbon dioxide we emit. I think we discussed it in a previous episode as well. But this absorption actually comes at a cost. When oceans absorb the CO2, essentially the seawater absorbs the CO2, it forms what is known as carbonic acid, um, leading to more acidic oceans.
Yeah, but so these acid oceans spell trouble for marine life. Creatures that rely on calcium carbonate for their shells, skeleton, like corals, for example, mollusks, and some plankton species. They will find it harder and harder to survive. And when these foundational species are threatened, entire marine ecosystem feel the impact.
Yeah, and beyond marine life, ocean acidification can actually disrupt ocean currents, the natural processes that that regulate our planet's climate. So the boundary here focuses on the saturation state of seawater with respect to a mineral called aragonite. The safe threshold is 2.75, and we are inching closer to that limit day by day.
Yes, but also let's think about a second about what it means just 1.5 degrees more on water. But when you talk about all the volume of water in the ocean, think about the energy that is needed to warm up all this volume of water by 1.5 degrees. So it's a huge amount of energy that will be concentrated in the ocean. But so going back here to oceanification, um, there is a silver lining. So addressing our CO2 emissions directly impacts ocean acidification. So if we transition to sustainable practices on land, definitely we can help heal our oceans.
Absolutely. Okay. So let's pick up maybe the third boundary here, which is stratospheric ozone depletion. So before we go into the details, here's the good news, right? So this is one where we are still in a safe operating space with respect to this boundary.
Yeah, and this probably give us hope because we were able to change the trajectory here. So many of us have heard about the ozone layer and its importance. This ozone layer acts as Earth sunscreen, protecting life from harmful ultraviolet radiation, UVs. But certain chemicals, as CFC, so chlorofluorocarbons, which were commonly used in refrigeration and aerosol sprays, have been thinning this protective layer.
Yeah, and the consequences of this can be severe, right? So increased ultraviolet radiation can lead to, cases of skin cancer and cataracts in humans. It can also harm animal life, especially those living in or near aquatic ecosystems.
So the good news, as we said before, so global action, particularly the Montreal Protocol, has led to significant reduction in the production and use of many of these harmful substances. So the ozone layer is showing signs of recovery, but it's a slow process and continuous monitoring is essential.
Right. Okay, moving on. Let's take our fourth boundary, which is freshwater use. Here we are again beyond the safe boundary and well into a zone of increasing risk.
Yeah, that's worrying. So as we know, water is essential of life. And while, as we said before, our planet is covered in it, only a small fraction is fresh water available for consumption. And with growing populations and industrialization and demand for fresh water is skyrocketing. This boundary focuses on sustainable use of freshwater resources, ensuring that we don't deplete rivers, lakes, and underground aquifers.
And over extraction, even of water, can lead to rivers, running dry, dropping levels of freshwater lakes, and shrinking underground aquifers. And this not only affects human population, but also disrupts ecosystems that rely on these sources of fresh water.
It's not just about quantity, quality matters too. So pollution from agricultural runoff, undertreated sewages, and industrial processes can contaminate freshwater sources, making them unsafe for consumption and harming aquatic life.
Yeah. And looking into the solution space, actually, the solutions lie in sustainable water management practices, efficient irrigation, reducing water waste, and treating wastewater to ensure it doesn't pollute other sources of fresh water.
Yeah. Now let's move from water to land, and so we tackle the fifth boundary for actually the latest for this episode, this land system change. And this boundary revolves around the idea that land, especially areas covered by forests, plays a crucial role in maintaining Earth stability.
Yeah, and forests are not just habitats for countless species. They're actually also great sinks for carbon that absorb more CO2 than they emit. Right. So with the increasing deforestation caused by agriculture, urbanization, and other purposes, we are losing these vital ecosystems in the form of forests. And we will talk about carbon sinks in one of our next episodes in more detail. But already we can say that within the carbon sinks, forests are a major element here.
Yep, and the ripple effects are vast. Deforestation can disrupt local climates, reduce biodiversity, and release stored carbon dioxide back into the atmosphere, so further exacerbating climate change.
Yeah, and this particular boundary emphasizes the importance of maintaining forest cover, especially in critical regions like the Amazon and the Congo Basin. It's about striking a balance between development and conservation.
So sustainable land management, reforestation efforts, and policies that prioritize conservations are key. But understanding the value of our land, not just a resource, but a vital component of our planet's health, so we can make informed decisions for a sustainable future.
Yeah. So there you have it. Out of the 9 boundaries that we identified at the beginning, today in this episode we discussed 5, among which 3 have already crossed the safe limit, and 1 is very close to being crossed. So it probably suffices to say that we are in a difficult situation. In the next episode, we would be taking up the other 4 planetary boundaries, and unfortunately, the situation on those 4 isn't very positive either. But this is it for today. The 5 planetary boundaries. Thank you very much for tuning in. We look forward to an interesting discussion in the next episode.
Thank you, Rishi. Good discussion.
Thank you.
Thank you.